Howdy, this is Mrs. John for Year 12 Physics, and I'm making a series of videos with my notes on electricity, and this is lesson 1, an introduction to static electricity. If you like my videos, give me a thumbs up so I'll know I can keep going with these sort of things to help you. Right, so there are two types of charges. So there's the positive charge and the negative charge. Like charges repel, and unlike charges or opposite charges will attract. Now, most objects are neutral as they have the same number of positive and negative charges. So you've got an equal number of pluses and minuses. Objects that are charged can either gain or lose electrons. The unit of charge is coulombs, and the symbol for charge is a little q or a capital Q. Now, the charge on an electron is represented as negative q, and it has a value of negative 1.6 times 10 to the power of negative 19 coulomb. The charge on a proton is exactly the same size as the charge on an electron, but it is positive. Now, what is an electric field? It is the area around a charged object where another charge would feel an electric force. So if you don't have point charges, but I've just drawn this diagram to give you an idea. So we draw the field. It's a radial field if you could isolate a single positive charge, and the direction of the electric field is the direction in which a positive charge will move. So positive will always move towards the negative. So you have the field lines going out of the positive and into the negative. Okay. Now, the closer the field lines, the stronger the electric field. Now, you need to know about a uniform electric field. So where do you have a uniform electric field? It exists between two metal plates that are oppositely charged. So if you have two plates, one has a positive charge and the other one has an equal and opposite negative charge, then between the two plates you have a uniform electric field. How do you know these lines represent a uniform electric field? The way that you know that is that it's evenly spaced lines that are parallel to each other. Just outside the plates, the field is no longer uniform, so the lines are curved. Now, electric field strength, it depends on the potential difference or the voltage between the plates and the distance between them, and the formula is E is V over D, and the electric field strength actually has 2 units. So based on this formula, it's volts per meter. Now, if the voltage across the plates increases, then the electric field strength will increase, since the electric field is directly proportional to the voltage, provided the distance remains the same or constant. So whenever you get a question to say what happens to the electric field strength when one of these quantities is changed, you need to say whether it increases or decreases, and you need to say if it's directly or inversely proportional, and you need to also say which of these quantities stay the same for that to happen. Now, the electric field strength is also proportional to the force that is felt by charge when it is in the field. So if you have a positive charge here, what's going to happen to the positive charge? It's going to get attracted to the negative plate. Why? Because it feels an electric force. So this is another formula for electric field strength. It's force divided by charge. And so based on this, the electric field strength also has a second unit, which is newtons per coulomb. So there you have. And then I've done some questions on the electric field. So you could take a look at this and practice it. And these are just straightforward questions.